move around a lot more. And that means if you have a certain way of doing software engineering in one company and you move to a new one, then very clearly you're going to end up with a slightly different experience potentially. So I talked about an increasing complexity in software delivery, and I want to give you kind of two different examples for that. So the first one is, I want you to think about what software engineering looked like just a few years ago. Like I mean, a few years. When I started in kind of the 2000s, the software delivery was still very much a batch event that happens on a quarterly basis. And what I mean by that is you had these big walls with project plans, and you could literally tick off the activities for a cutover. And that was because you had a small number of systems, usually either a COTS system like package software or very large monolithic custom applications. And that was easy to do because you could then really have version numbers for the components. There was code frozen weeks in advance. That was a lot easier to deliver. Nowadays, what we have is we have small batch delivery. We have not dozens of components. We have thousands of components, thousands of microservices that you need to orchestrate. You're not releasing quarterly. You potentially release multiple times a day. And what you release is never really frozen. So there's a lot more movements in it. On top of that, we have a lot more software developers these days working on these products. And rather than just having these kind of shrink wrap software, you have lots of open source components in it. So that increases the complexity. And as a software delivery engineer, or release manager, or project manager, you have to deal with that complexity. And we haven't really focused on that for a long time. We built more kind of CI/CD pipelines, we built more automation, but we haven't really made it easy because then now we had dozens of agile teams and they all use different tooling. So we ended up in a world where there was more automation, but there wasn't necessarily less complexity. And one thing that demonstrates this really well, in my view, is when you just look at what kind of a DevOps platform and the DevOps ecosystem looks like. So here are two slides that coming from the internet, from kind of different sources, but they demonstrate the same thing, that for all the DevOps capabilities, there are dozens of options of what you can use. And so in very large organizations, if you're working in really large ones, you might have pretty much one of everything. And you can see how that adds to your complexity as well, because when you move between teams, you might move between very different technology stacks, very different tools. If you move to different organizations, you might yet again learn a new set of tools. And what that does is it really increases the cognitive load on your developers, that they have to figure out how to deal with this, and they're kind of relearning all the time. So dealing with this, and I think that's why developer experience has become increasingly popular, is organizations focusing on developer experience are curating the experiences for the developers to make it easier to achieve the things that they need to do, to make it easier to allow them to do the right thing rather than doing the wrong thing. Now, that is one aspect, which takes complexity, well, cuts through the kind of the jungle of tools and technologies and different things. But there's another aspect as well. Developer experience is not just reducing complexity, it also puts the software engineer in the center and should make that person as effective as possible. And so how can we do this? How do we get effective software developers? And I want to start with the kind of the principle behind how software engineers think. And I personally really like the work that Dan Pink has done around what motivates people. So how can we unleash that full power of your developers? And what Dan Pink says is that people who work are knowledge workers, which means they're working in kind of complex environments that are not repetitive, where every problem is kind of a new problem. The things that motivates people are autonomy, mastery, and purpose. And if you think about autonomy, mastery, and purpose, there's actually a ton that we are doing with modern delivery methods that allow us to really kind of enable these three aspects of work. So think about purpose. Purpose means I'm getting up in the morning, knowing why I'm here, like what I'm actually trying to achieve with the organization. And in the past, certainly when I started working, you had a very kind of mechanistic way of thinking about it, nearly like in a manufacturing factory, where there was a design somewhere and that was translated in a technical design, and the technical design was broken down to component design, and then the component design was handed over to an engineer. That engineer implemented the component, handed it over to a testing person, they tested it, And then at some stage you might have gotten some feedback, but the feedback might even have gone to a fixed team. Now that doesn't create purpose. What creates purpose is understanding the business problem you're trying to solve. And when we started talking about agile methods, features, user stories, we ended up starting to enabling a lot closer connection to purpose for people. Product management and being able to actually see the business measures, not just the kind of functional measures of your product, bring you a lot closer to your customers. Like, how many people do we get through a product funnel? How many people are buying my product? How many people are using the features that we are putting out there? So a lot of that helped us enable purpose. And we did this also by reconfiguring our organizations. So we got these vertical integrated teams, the DevOps teams, that had Dev and Ops. They owned their own infrastructure. They were able to build components end to end. Then you had autonomy. And autonomy is sometimes even harder to achieve because there's a lot of dependencies in organizations, especially when you work with large systems. But decoupling the architecture allowed us to have smaller teams, microservice teams that are, teams owning one or more microservices, for example, that are completely independent. They can deploy independently. They have backwards and forwards compatible interfaces. They have these kind of API contracts with other parts of the organization, and they can work by themselves. We also enabled through CI/CD pipelines developers to directly get feedback, so that they didn't have to wait for testers to come back. They put their code in there, the code gets supported through the CI/CD pipeline, and then you get the feedback coming back in. And then lastly, mastery. And mastery is really achieved through feedback. Like, if you never get any feedback, you can't really get better. Now, the CI/CD pipeline has been very crucial to give you technical feedback, as I described earlier. But then there's also business mastery, understanding whether the work you're doing really solves the business problem. And that comes down to, when you deploy something, can I see people actually using features in production? So I was working for a telco company a few years ago, and we were working with the people in the call center. There was a CRM system that we were implementing. And one of the things that we decided on very early on was we would build into our features the measurement, the logging of whether people actually use it. Because what uses our features that we've nicely thought about if we roll it out in production and no one uses it, no one presses that button? So we created that kind of feedback cycle so that we could see what features were used. If features were not used, was it because technically it didn't make sense? Or was it change management? Did we have to educate people better on why we are doing it, what benefits it provides? And that really changed the way that we build solutions, to try to make it more intuitive, but also to spend more time on the communication side of it, of showing people why what we're doing is beneficial. Of course, if you are a user of modern platforms and on social media, like something like Facebook, you never really get a manual or a change communication that say, we moved this button around or whatever. They're trying to make it super intuitive. I think organizations very often have a bit longer to go for that. But thinking about that and understanding whether things are being used correctly is crucially important for that feedback cycle. So we talked a little bit about the complexity that we want to break through with developer experience. We spoke about what motivates people and what we want to enable. So let's bring this together in what DevX really looks like. And on the next slide, I show you kind of what this could feel like when you are moving into an organization that takes developer experience serious. So the first thing on the left, you see, if you're joining an organization, if you are one of the engineers, that means you are, you've been hired for your technical prowess and how good you are in building tech solutions. The onboarding experience should be seamless. Like, you should be able to be productive very quickly. Unfortunately, many organizations, that takes days or weeks for you to get all the security access, get access to all the systems that you want to use, get able to the repositories that you need to be enabled on. But that should be something that we really focus on. If I'm a key employee, I shouldn't have to sit around for weeks getting just my technology sorted. And nowadays, we obviously have artificial intelligence as well that should be able to advise you and give you guidance and says, okay, you've joined Project Phoenix. Well, here are the repositories, here's your CD pipelines, here's the documentation, here's the starter guide. And you can interact with that digital advisor to basically give you guidance as you make yourself comfortable with the new technology stack that you're working with. Then in the middle, you see the developer marketplace. There's many names for this. Internal developer platform, platform engineering comes from that. You might use technologies like Backstage, but that is really the thing that you're interacting with. And that should be as comprehensive as possible so that you don't have to log into 4 or 5 or 6 different systems. And then on the right-hand side, you see another aspect that is really important for developer experience. And that is the actual career experience, like from starting and getting productive, either as a junior developer or as someone new in the organization, through creating this purpose. Remember, I talked about understanding why you're building solutions, and then obviously scaling and managing and having more and more influence and starting to freestyle more, starting to innovate, trying to find new creative ways of solving problems for the business. To support all that, you need to create an ecosystem that does that. So anything from communities of practice, guilds, the right innovation environment where you can easily create a sandbox and experiment with your technology stack, with your products, but also the ability to, in a safe way, experiment directly in production with systems. Right? So creating this whole career model, in my firm where I work, we've created something called the Chief Technology Engineer. And that career model really enables people not to have to do people management, but just manage larger and larger technology solutions. Because, for some people, they might not really enjoy managing people that much. They rather solve really nasty technology problems. So those are kind of the full spectrum. And I talked a little bit about this thing in the middle, the developer marketplace. And I want to just deep dive a little bit more into what systems look like and why this is so important. We've been talking about DevOps for years. And one of the things that I personally find quite frustrating with it is we keep talking about culture, but culture is nothing else than experience processes and behaviors. Now, what you see here is a typical experience of a developer. If I want to do development, I very likely go into a system like Jira. Right? I have my user stories, my features, my tasks. I go in there, pick up my work, and start developing. If I'm an ops person, I very likely go into something like ServiceNow, where I get my tickets. Or if I'm a business person, I'm going to something like Power BI to get how my business is running. Now, if these systems are completely different, by looking over the shoulder of someone and seeing where they log in, you know who they are, you know what role they're playing, and you know what mindset they're in. So if we truly think there's a DevOps culture that we want to enable, we need to enable these developer experiences that merge these things so that I have at my fingertips what is my kind of development needs, what are the things that I'm creating newly, what backflow do I have from production in regards to tickets and problems, and how is my business doing? How is my specific component that is supporting the business actually doing that? If we do that, it is a lot easier to see how people understand their own context and see every day what is going well and what is not going so well. The other thing that we want to think about in all this is in the end-to-end workflow. So development, as very often instructed through Agile and in Jira, is a planned exercise. We're going to do sprints, we're going to look at our backlog, we're going to pick up something for that specific period, and we're going to execute this over the next 2 weeks, 3 weeks, however long your sprint is. Production defects and incidents are unplanned. So they come in through a different system. Like you can't really plan for them in a sprint. So we need to accommodate that as capacity within the team that we allow ourselves. And then you have transformational needs, whether that's your technology transformation, whether it's because you're changing your tool set. And so you need to make space for that as well. So we can't force people in a one-size-fits-all methodology unless you can actually accommodate these different types of work. Otherwise, we're back into the same old system before, where depending on what methodology you use, you can tell whether you're a dev or an ops person. And that, I think, is really crucial for us to enable systems and developer platforms that allow us to do this successfully. So let's talk about these platforms. The very first things I want to say is an internal development platform is not just a technology platform. It is a socio-technical system. And what I mean by that is it's not just the tools that you enable. It is the processes, it's the organizational structure, it's the way that you organize the architecture of the systems around that. Because if you just put different tools in front of someone, that doesn't necessarily change the behavior. Right? If you still have testing organization, development organization, ops organization, having a joint developer platform will basically mean everyone will use it differently. Right? So you really need to think of this in the way that all of these things interact with each other. But there's a technical component to it. And the technical component you can see here on the left-hand side as a reference architecture. So some of this is represented here of what I said earlier. You see in the left top the SDLC management tooling, as I referred to earlier, something like Jira. On the right-hand side, you see the service management platform. That's where the production tickets come back. And then in the middle, you see the IDE, my core interaction system, where I'm actually writing my code, combine the components, and so forth. Now, as I said, I want to make this as seamless as possible. So ideally, they're not 3 different systems, but they're different components being exposed to you in one common platform. Underneath that, you see at the very bottom a cloud landing zone, and that is ultimately all the networking and storage and compute that you want to compute into your systems. In the middle, you see the data platform. That is important for you to get information directly from production data, where you are calculating things, where you want to understand your customers, your product catalogs, all those kind of things. But you also want to be able to mask things that is not required for you to see as you're going through development. So things like credit card information and other personal identifiable data. On the right-hand side, you see the container platform managing and orchestrating your microservices and your containers. And then in the middle, you see the software engineering platform. And the software engineering platform is where all the traditional CI/CD stuff did. So anything from testing, from static analysis, security tooling, build tooling, deployment tooling, your launch Darky to do feature flags, all that sits in the software engineering platform that orchestrates everything else around it. And then at the top of that, you obviously want to expose a lot of this through APIs to your developers so that they can freestyle. Like the more comfortable they get with your platform, you want them to be able to combine this in the way that supports their work best. On the right-hand side, you see some of the implementation consideration. And I think for too many organizations, the internal developer platform has become something that is very engineering driven. And what that does is it creates a better mousetrap that not necessarily everyone buys into. So how do you create an ecosystem around this that people want to support? So creating a dedicated team that actually supports this, so that when people have questions, when people need help, they know where to go. You want to create this thriving internal developer community. The people who really care about this, the people who advocate this, the people who, when there's a new feature available, screaming from the rooftop saying, hey guys, we have this new thing now, please use it. You want to enable developer journeys. You want to, if my job is to put APIs out in production, then there should be a journey that enables this and that minimizes the touch points I need with different systems for it. Yeah, so developer journey is something that you map for your different groups of developers to understand, okay, what's the process they have to go through? What approvals do they need? What enablement do they need? And how do I minimize the amount of wait time and touch points with different systems? You want to measure. You want to understand that you're actually using the successful net and providing value. And I will talk about that a little bit more later. And then you want to make sure that you're also using the right componentry, right? So how much of that is open source? Is all the benefits and risks that come with this? How much is commercial software? And all that ultimately to make it easy to do the right thing and make it increasingly harder to do the wrong thing or to make a mistake. And remember, when someone makes a mistake, that's an opportunity for you to think about what could be built on the platform to make this better. It shouldn't be blaming Bob or Jill or Jane to say, hey, you're not using the system wrong. Use it as an opportunity to make it stronger by providing better guidelines, better help systems, etc. So as you build these systems out, there's kind of a crucial way that you enable that. And you can see this here on the left-hand side. And what I'm trying to show in that diagram is the better you get with your system, the more demanding platforms you can support. So think about it. If you're only having to support internal SharePoint, you don't need a ton of external security scans and those kind of things. So you can very quickly start supporting that with your platform. But if you have a highly performant financial transaction system, then you have to have a completely different set of capabilities in your platform around performance testing, around the capabilities to test that, about the security around it. So you want to build this out incrementally. Don't build an internal developer platform to support everything and then roll it out. Learn from it. Start with something that's less demanding and then build out to it. And also build out the different technology stacks. If you have different cloud providers, if you have different kind of componentry that you need to support, don't support it all. Pick some applications, move them onto it, learn from it, and then evolve. On the right-hand side, you see how what we are building is really becoming that mesh that supports your organization, that allows people to manage dependency between them as well. Think about those APIs that you need to manage and the back and forward compatibility that ideally you enable. But not always be able to do that. Yeah, so you're creating a decoupled system that this internal developer platform and its componentry enables the smooth running of the organization. Now, I talked about measurements, and I know that's somewhat controversial, and nothing showed that better than a few months ago, McKinsey published their software development productivity measure blog post. Now, to be honest, there's not a ton that is wrong there. They talk about DORA metrics that many of you will be familiar with. They talk about the space metrics that I think many of you might be familiar with, coming from Google, I think. But they got the intent wrong, right? They talk about this as if you can measure individual developers, which isn't the intent. The intent was very different. And you can see this in the back, like, the post that came afterwards, they say, oh my God, this is completely wrong. Oh my God, how could they do this? They are using metrics. But realistically, I think they were just a little bit off. And you can just see how in the age of social media and where people try to look for a reason to disagree, there was a lot more commentary about what was wrong rather than focusing on the stuff that they got right, which I think is a bit of a shame. It probably doesn't help that it's a consulting company, mostly business consulting company, publishing it. But hey, I do think, however, without measurements, you do not know whether your platform is working well. So you need to do something. I'll show you what I use. And again, that might not be everyone's flavor, and it might not be necessarily what people like, but this is what I use. I use this kind of balanced scorecard. And the balanced scorecard here has 4 areas. And I'm not going to go into the details of all the metrics. I'm going to give you how I structured it. And with pretty much every organization I work with, it is structured a little bit different underneath these specific areas. But the areas stay the same. The left top, you have business effectiveness. Business effectiveness means these are the things like how quickly can I experiment? And if my experiment is successful, how quickly can I expand on it? How quickly can I roll it out? So a lot of this is about feature usage. It's about kind of the user funnel. Are people actually pressing the button that I put out there or using my feature? And if I've partially rolled it out, can I then very quickly adapt it for everyone else? And how many experiments do I actually run? On the right top side, you see delivery efficiency. That is speed up and automate. That is the CI/CD pipeline. That is, as soon as I have written the code, I want to get it out there as quickly as possible. So what can I improve there? There's this time to feedback. This is kind of how reliable my deployments are, how many manual steps I still have to go through. Those are the metrics that sit there. Left bottom, operations reliability. The best system in the world doesn't matter if it's unreliable. So in here you see things that are about reacting to something and automating things. So it's kind of sensing that there's a problem, ideally automated rather than a user telling you that something's wrong, and then automatically reacting to it. So you see things in here like proactively found defects, the amount of things that have been services that have been automated so that people don't need to create a ticket that goes to a person, automated password resets and other things. And then in the right bottom is the most complicated one, which is architectural flexibility. Remember, I talked about these big monolithic systems that are really hard to manage and where you have lots of dependency between different teams. Well, this is the measurement for how do we decouple something? How do we make the individual components smaller? And how many of these interfaces are forwards and backwards compatible to allow us to move independent from each other? So I think that's a pretty good scorecard. The individual metrics will change on your context, on your organization, but overall, this tends to work quite well. One thing to remember, they will not all move forward in the same direction. Like sometimes when you make a change, one of them move forward, another one moves backwards. And that's completely normal. That's the whole benefit of a balanced scorecard, that you can start seeing the balance between these different things and then react to that. Well, I'm at the end of my 25 minutes. It was an absolute pleasure being with you guys today. If you're interested in more, I do have a blog post, a blog that I occasionally blog at called Not a Factory Anymore. Very much that principle of I don't agree with people who call things software factories, because I think it's a creative endeavor that our developers go through. And I'm also the author of a DevOps for the Modern Enterprise, which I wrote a couple of years ago about basically what like the early iteration. It doesn't talk about developer experience yet, but talks about how to adopt DevOps in complex organizations. So thank you very much. I will leave you guys for the rest of the sessions today. Thank you.